Hello, everyone, and welcome to Verosint Live. Another session is here for you today. We are excited to bring another great topic to you on the subject of account fraud and stopping fraudsters in their tracks. I am joined here today with Mark Batchelor and Travis Favaron. They're going to be discussing all things SignalPrint with you. So I'm going to go ahead and turn it over to them, and if you have questions, please hold them until the end and we will try to answer them if we have time. Travis?
Awesome. So what is SignalPrint? Well, a little bit about what we're going to go through today is obviously the topic of what is SignalPrint, how it's different than a more traditional browser fingerprint. We're going to spend a little time going through the SignalPrint Explorer, a feature of our application, show you what that looks like and maybe how a SignalPrint manifests in the product itself. And then start to touch on how SignalPrint can help you improve both security and user experience through being more adaptive and nuanced in your user flows. So Mark, I'm going to pose the question to you first. What is a SignalPrint?
Yeah.
Give us a high level overview.
Yeah, of course. So a SignalPrint, think of it this way. All of our internet identities carry around attributes with them, right? So when I go to a website or I go use an application on my phone, I may log into it and I may use my email address. That email address has attributes associated with it. What is the domain that hosts the email address? How many breaches has that email address been in? Is it on any known, malicious email lists or things like that, right? The IP address I'm using has similar things. What's the geographic location that it is associated to? What provider owns that address? Is it a known bot or a known Tor node? That type of thing. Same thing for my phone number. If I happen to be using my number, am I on a do not originate list? Am I on a set of known spammer lists? Right. So it's a collective data about a handful of attributes. In this case, it's email address, IP address, phone number, and a user agent or app ID, for example. It's the data behind those that make up the unique entity that becomes the SignalPrint. So the way we do this, and the way we even create, the reason we even create SignalPrints is I'm kind of parlaying you into your next thing here, Travis. The technique we use to create SignalPrints is a way to create a fingerprint for a user without asking for things like a browser canvas or some other sort of intrusive client-side thing. And then we use these prints to do all sorts of interesting fraud detection, which we'll get into. But that's a SignalPrint. Does that make sense, Travis, or do I need to elaborate some more?
No, I think that's a good overview. I'd add that these prints are created through kind of consuming the identity events from your identity flows and your existing infrastructure today, entirely kind of behind the scenes, if you will. So it's server side. You mentioned not client side. This is starting to transition to the topic of how is it different than a browser fingerprint. But it's a passive way to understand and give a unique identifier for a user that's not necessarily their user account. And that's what lets us determine and ask questions, the answer to questions like, is this entity that's interacting with my service right now probably Mark Batchelor, the user account that they're using, or is this really different than what I typically see from Mark, and maybe I need to ask a few more questions.
Yeah. And just to add a little bit more, again, the way we do that is we look up data about the entity as it comes in to create these fingerprints. It's not the same, but it's a similar sort of technique to what you might see an advertiser almost do, for example, that follows you around the internet. Now, we're doing a bunch of different stuff for security purposes, but it's similar in that they're looking up attributes in order to create a unique identity for yourself. So,
well, maybe this is a good time to transition to kind of showing how this manifests in the product itself, and what, as a customer of Verosint, you could see how does SignalPrint show up? How can you explore them? What kind of data and power does it give you to drive different identity flows and find fraud?
Yep. I will go ahead and jump into showing you the SignalPrint Explorer. Can you guys see that okay so far?
Yes,
Yep.
looks great.
All right. So what you see on the screen here is our SignalPrint Explorer. And what happens is that we use SignalPrints in a couple of different ways in our products. We can do what we call passive printing, which is just creating what you see here on the screen. So maybe you add us to a login flow at Auth0 or Ping Identity or something like that. And as users log in or register to the application, you pass us a little bit of information. Again, it was email, IP, phone. And we look up the data for that stuff and generate these signal prints for these users as they flow through. So, I may register the first time and then come back a few days later and log in. I'm coming from the same device, maybe, but maybe the IP address has changed. So we're generating prints and we're either creating new ones or updating existing ones if I happen to be that same person, right? If I look the same as I looked before. And that's what you see here on the screen. This is some demo data that we use. And I'll just kind of drill into this large beehive here. What you see here on the screen is the blue dot in the middle is an account. The yellow dots they actually represent the prints themselves. And so what we're doing is when somebody successfully logs in, we generate a print. Think of the yellow dots as a device, right? So we generate a print for that device. And then once they successfully logged in or registered, we then associate that account with that print, right? And that creates this combination you see here of prints to accounts. What happens is, in this case, you can see that this is a single account with a whole bunch of devices, right? To us, this gets manifested in our product. And it'll get tagged as account sharing. So this is one account that's sharing their account in multiple places. And we'll tag that, right? But more importantly, since we're talking about signal prints in general, is on this right, if I click on the account on this right-hand side, you'll see the attributes about that signal print. So not only will you see the signals that we've generated for it. So in this case, this person's done impossible travel. They've been a new print and they're associated with account sharing. I can also break down their attributes and look at the underlying data behind them. So if I click on the email address, for example, I'll see that one of the signals associated with this particular email address is that it's a free email provider, right? And that I could write a rule against that and say, I don't want people with free email providers to use my product. But if I came back later and more signals get added to this, if suddenly this particular email address gets added to a spam list or a deny list, those signals are also going to show up here. And the signal print for this particular combination of account to print is going to change a little bit, right? So now I've got more signals and my print looks a little bit different. Has enough change to make it a different print? Depends on what changes, right? If I come back over here, I can look at, say, the locations that I've come from. This is all the impossible travel. As you can see, this is obviously some test data, but sometimes what a botnet might look like if they're coming from a bunch of different VPN providers or Tor nodes. I can dig into the IP, the print itself, and see what actually made up the print. So there's this user agent, there's an account ID, there's an email address associated with it, right? And you can see this one actually has a whole bunch of different prints. I can look at the IPs and go look at them in general. This one happens to be located wherever this is. I don't know where that is. Latvia, I believe. And it came from a mobile Safari browser, but it's also been flagged as having to be a known proxy and a known VPN provider, right? So I could write rules on that. But all these attributes about the IP, the email address, and a phone number, if there is one, make up the print. So far, so good, Travis? Make sense? Yep.
Yes.
Okay. Just to, I don't know, click on another one here just to show you a couple other ones. Here's another one that's associated with multiple account abuse. This happens to be mail.ru, also a free provider, coming out of looks like the Northwest. If I look at one of these, this has a hosted signal and a proxy signal. So this is actually probably an Amazon data center, coming out of a data center. But again, these attributes make up that print. If a whole bunch of them change all of a sudden, I'm going to get a new print. And so the way that we use it in a login is when somebody gets printed the first time, that's the first print, obviously. They come back again if, some larger percentage has changed. So maybe they're now on a new ISP, maybe they've gone to a coffee shop, right? Maybe they're suddenly in a whole bunch of new breaches for some reason. We can then run rules against that during login to tell your IAM platform what to do next. Like, this print doesn't look the same as it did last time. It could be Mark, but Mark changed quite a bit, right? So, Mark got a haircut and he doesn't usually dress like that. This is kind of the analogy here. So you should ask Mark more questions and make sure that it's Mark. So MFA Mark. That's how we use these prints. Make sense?
It does. And I would add there that things that change extremely commonly, so like minor changes in IP address or other pieces of information that are almost expected to change with normal behavior, the SignalPrint is kind of resilient to some of that change. It requires a change of kind of consequence and significance for the triggering effect of like, hey, this is potentially a new person and a new print. Let's trigger a flow. So it's not that just a minor change and you're getting a new IP address or something is going to immediately trigger everything. It would be a more significant change than that.
Right, and the analogy that I always use for that one is the sort of home ISP. At home, I'm on Comcast. Occasionally my IP address will change, right? But Comcast is still the commercial provider. I'm still in the same general location I was before, latitude, longitude, right? All that changed maybe was a decimal place at the end of it. So not enough changed. It's probably still Mark, so we can make that assumption, right? But if I go from Comcast internet to Starbucks Wi-Fi over here, I think it's Google, then that's a significant change. I'm no longer on the same provider. I may be in a similar geographic location, but I'm no longer on the same provider. So enough has changed that it likely generates a new print.
Yeah, awesome. And that kind of takes us to the last point. We touched on it already, about how the power of how this lets you kind of drive adaptive workflows, and being able to know, almost a recognition score of, do I recognize this interaction for this given account, lets you be a little more nuanced with things. You don't necessarily have to sacrifice full security of, I want to have MFA. I want to have all of these additional security measures to make sure that people aren't getting unauthorized access to accounts. That's great, except that most cases are not unauthorized access. Most cases are authorized access. And so the more you can be nuanced and not burn out your end user on having to perform the security challenges, the less at risk they are to those kind of burnout. MFA fatigue being a really interesting example where there are cases of account takeovers happening just simply because an end user was getting pestered with push notifications to allow an MFA request, and finally they just got it to stop by hitting allow. And so that having situations where you're not having to condition a user to like click allow every time they have to change browser tabs or log back in after lunch, or change windows like that. Those types of situations, you can reserve the security measures for kind of higher impact events and or higher risk interactions.
Yeah, yes, it's very much about trying to take the right action when it's required. When enough things change that you need to take that action versus taking that action every single time. I might make Melanie smile with this one. The analogy I like to use with this one is this guard shack analogy. is, I'm a guard at a guard shack, and Travis, it's your first day at work. You show up. I'm going to ask you a bunch of questions to make sure it's you. Show me your driver's license, right? After a week or so of you showing up for work, I'm used to Travis coming in. I know what Travis is supposed to look like. I know what's normal for Travis. So I just let Travis into the building, maybe swipes his badge, right? A month goes by, Travis shows up and he's wearing a trench coat and a bunch of tactical gear. Something changed with Travis. It's still Travis, probably, but something changed with Travis. I should really stop Travis and ask him more questions. That's the analogy we use here for most of the stuff around SignalPrint, is that, establish the baseline, and when something changes enough, ask them the right question based on sort of what changed, to be able to be comfortable with that it's the person you think they are. So I had to get that out there for you, Melody. I know you like that. Yeah.
Awesome.
Travis, one thing we didn't cover yet is, how is this different from a browser fingerprint? And I think that's a common question we get, is, why wouldn't I just implement browser fingerprinting? Well, you might, right? You might still implement browser fingerprinting for a handful of reasons. But this differs significantly from that, in that there's nothing that runs on the client side, as Travis mentioned before. This is all server side. And because of that, A, it's fast, right? And B, it is, it survives things like incognito windows. It survives things like, blockers and things like that. This is about security, not necessarily about tracking, right? And when you think about browser fingerprinting, a lot of it took to life because of tracking purposes, not necessarily security purposes, and it kind of ended up in the security realm in some cases. It's a good technique for it, but it's pretty intrusive. And like I said, with our server-side techniques, it's fast, unintrusive, and we purpose-built for security reasons. So just wanted to put that out there.
Awesome.
Yep. What was next? Are we missing anything?
I think that was pretty much the end of our kind of planned demonstration. But before you kill the screen share, we did have one question come in around how to see some of this stuff. Like, can you see some of this in a dashboard? So maybe we jump to the fraud overview and just real quickly discuss that and how kind of the SignalPrint data shows up here.
Yeah, sure. So we've got a couple of different dashboards, and this is your data over time, or your data in real time in this case. How many events we've processed, how many prints we've created, how many things we've flagged as potentially fraudulent signals or fraudulent activity. So in the case of this account, you can see that there's 792 accounts associated with account sharing, 93 multiple accounts. There's been a bunch of impossible travel. I remember this is demo data that we're doing this on. Which signals we've evaluated that came in as parts of prints, that how they rank, right? So what do I have the most of? I've got the most free signals, meaning I've got the most email accounts. My highest signal is email accounts that are free, Gmail, whatever it happens to be, right? I've got a lot of account sharing and impossible travel, a lot of proxies and hosted. What I can do with the dashboards here is not only just look around to see what's happening, but I could also get an idea about what might be occurring right now. So, maybe I'm suddenly under attack by a botnet, or and they're using free Gmail accounts. If this isn't one of my normal signals, and maybe this bubbles up at the top a lot, I should probably go look at this and see what's actually happening in here. So we can kind of dig through these. I can see when prints have been created. I can also jump to specific dashboards in here. So I clicked on impossible travel there. So this is going to show me everybody that's doing impossible travel, when they did it, when the uptake was, where they're doing it from, and then the signals associated with the impossible travel people, right? So proxy, they're coming from a lot of proxies, a lot of hosted environments. That type of thing. And then who's doing it. So if I want to go look at, this person, I can go click on it and it'll take me right there to it in the SignalPrint Explorer. and then I can find out who it was, and then I can look at their prints and see what's happening. So yeah. We've also got some dashboards in here for signals and everything else. I think that's probably we can do an entire thing on dashboards in general, I think. But
Yeah, maybe save
yeah.
that for another day.
Yeah. The last thing I wanted to mention here is that we're going to go over this on the next, I think, Verosint Live. Now that we've talked about what a signal print actually is, and sort of how you view it and look at it, we're gonna go through with, great that I can see these things. How do I build something to evaluate these things, and then do something like adaptive identity proofing or adaptive MFA, right? And we'll go over rules next time around, and we'll talk about adaptive, and then how do I take action on these signal prints is what we'll talk about next.
Awesome. Yeah. Exciting. Well, a quick summary before we wrap up here, right? Like, so SignalPrint is a unique identifier we generate from the identity events out of your existing identity flows. That gives you a bunch of data after we enrich it with risk and OSINT signals and all of the stuff we showed you here today. You can see that both in the SignalPrint Explorer and in the fraud dashboards to help you identify which are your kind of most problematic areas and what the makeup of your problematic users look like, such that, and we'll get into this next time, you can take that data and apply it in rules to start having targeted security measures against those bad actors to let kind of your typical good actor through without any significant friction.
You got it.
All right. Well, last thing I'm going to ask you to do is if you head to verosint.com, we offer a free trial, which is pretty generous as far as its capabilities. You can see everything from the product there, try it out. You can send in your own data if you want, check out the demo data, some of the same things you were seeing here if you want to play with it yourself and see how real it really is. So there's free trial available on the website, verosint.com/free trial.
Awesome. Thank you both. This has been great information, and be sure and get signed up for our next Verosint Live, happening every Monday at 3 p.m. Central. Thank you.
Have a good one, everyone.